Hello, in this video we are continuing our discussion of section 7.3 on the shell method by working through a third part for example 1. So we still have the same region that we're rotating, and part 3 we need to rotate it around the line y equals 2. The line y equals 2 is already written here, so all we need to do is consider rotating around this line. Now this is a horizontal line. As with the previous sections, we are going to draw a line that is parallel to our axis of revolution. This is indicative of one little shell that's going to get rotated around the line y equals 2. Our shell height ends up still being the same as we've seen in the previous two parts, because of the fact that, again, like part 2, the only thing that's changed is the axis of revolution. So we know from the previous part that our shell height and our bounds of integration should stay the same. So just copying these from the previous part, the shell height is going to be y squared plus 2, because that's what happens when we rearrange our equation for y equals the square root of x minus 2, and the bounds are still going to be y equals 0 to y equals 2. Notice, since we still have a horizontal axis of revolution, we are still going to be doing everything in terms of y. So the only thing that's changing is the shell radius. For the shell radius, we need the distance between our indicative shell with our little line segment to our axis of revolution. Since our axis of revolution is above the region that's being rotated, that means that we need the distance from this line above our little line segment. So in words, the shell radius is still the same. It's the distance from our line segment to the axis of revolution. Now our axis of revolution in this case is y equals 2. So to determine the shell radius now, we need to think about the fact that we know this distance between our line segment and the x-axis, that's always y. Same thing as with the last two problems, so that's y. We know this entire distance is 2, because this is the line y equals 2, but we want to know this little distance that's left. So we need to take the total distance 2 and subtract y from it. So this means we're going to have 2 minus y. We have this sort of subtraction whenever our axis of revolution is above the region that's being rotated, and it doesn't matter whether it's directly beside but above, or directly adjacent but above our region, or whether it's way above the region so that there's a gap. Gap doesn't really matter with the shell method. It all gets taken into account with the bounds of integration. Okay, so we have all the pieces of information that we need then. The volume in this case is going to be the integral from 0 to 2. 2 pi, our shell radius is 2 minus y, and our shell height is y squared plus 2 dy. So there is our final answer for part 3. And again, notice, since we're still going the same direction, we still have the same orientation, but we've simply moved our axis of revolution up. The only thing that has changed from part 3 to part 2 and even to part 1 is our shell radius. Everything else is the same.